Okay, so just want to make sure that we continue our 6-4 just to go through some of these transformations. And we talked a lot about them yesterday. We didn't actually try to do any in function notation. So let the graph of G be a reflection in the x-axis, okay, followed by translation 3 units right of the graph of f of x equals 2 to the power of x. So the reflection in the x-axis, we're going to call that h of x. Okay, if we're reflecting in the x-axis, are we going a vertical or a horizontal reflection or movement? Yeah, when we're doing x-axis, it's a vertical. Okay, so that means, does it happen inside or outside of the parentheses? It happens outside. So h of x, actually let's use the same pen here. H of x is going to equal negative f of x. Okay, and so f of x is 2 to the power of x, so we get negative 2 to the power of x, which is negative 2 to the x. That is h of x. That negative sign is like your a term out there. All right, followed by a translation 4 units right. That's going to be our g of x. Okay, right and left, does that happen inside or outside? Inside. So we take g of x, and that's going to equal h of x. Going to the right, are we adding or subtracting?
Subtracting.
Subtracting 4. So that piece right there is getting plugged in for x. So we end up with negative 2 to the x minus 4.
Good morning. In just a moment.
Okay, so let the graph of G be a translation 2 units up. Hey, quiet please. Followed by a vertical stretch by a factor of 2. Okay, so if we use translation 2 units up, that is going to be h of x equals f of x all plus 2. Okay, and so we plug in our log base 1/3 of x and then add 2 to that. So we end up with h of x equals all right. And then for g of x, stretch by a factor of 2, it's a vertical stretch. So we take, we go g of x is equal to 2 h of x. All right, and so that ends up giving us 2 times log base 1/3 of x plus 2. And here's where the mistake usually comes in. Forgetting to apply that 2, distribute it to both pieces. So that would be plus 4. Yes? No, it's all carried in when you bring it into this term. Yeah. Okay? Not okay? Yeah?
What would you do if it was a horizontal translation?
No, why don't we see if we have one of those coming up here? Oh, we do.
Oh, okay.
Horizontal stretch. And then followed by a translation 2 units up. And then we have a translation to the left here. Okay? So we'll do that on these. Okay? Number 7 and 8. Give it a go. Okay. Let the graph G be a horizontal stretch by a factor of 3. That's going to be our h of x piece. So I'm going to go h of x is equal to a horizontal stretch by a factor of 3. That means you are inside the parentheses. So that's going to be f of 1/3 x. Now remember, if it's a horizontal stretch by a factor of 3, we show that as it's kind of counterintuitive. So it's 1/3 x in there. Pay attention. Ethan. You got that? All right. So that gives me f of this 1/3 x gets plugged in for that x right there. Excuse me, we wouldn't have f there anymore. So that is now e to the negative 1/3 x. Okay? I'll make that e, that base, look a little bigger there. So negative, we put it in parentheses there. All right. And then the g of x, so followed by a translation 2 units up. So that's going to be our g portion. So we'll go g of x now, when we put it all together, gives us h of x plus 2. So we just take that, e to the negative 1/3 power of x, and we're going to add 2 to that. Still have that in parentheses there. That is our g of x, and you don't have to, like, you can rewrite it as e to the negative 1/3 power of x, all plus 2. Okay. Questions on it? Yeah. Because when we inputted it for x, and the negative already existed there. That's why I have parentheses around it. No. Okay. Number 8. This one, let the graph of g be a reflection in the y-axis. Okay. So we're going to call that reflection in the y-axis piece. That'll be the part we show with h. So h of x is equal to, if we're reflecting in the y, it's outside, or excuse me, it's inside. So it's f of negative x. So we're going to take f, which is log x. We're going to plug that negative x in right there. So that's negative x like that now. So that's our h of x. And then we're going to follow that by a translation 4 units to the left. So from that, that'll be our g of x piece. So g of x is going to equal h of x. And it's 4 to the left. That means it's x plus or minus. It's going to the left, so it's plus 4. Yes? Okay. And this piece is getting plugged in for that right there. So we end up with g of x equals log of negative x plus 4. Be careful, make sure that you put that negative like that so you distribute it to both parts. So you get negative x minus 4. Okay? Questions? All right, I want you to take out yesterday's assignment, please, the extra practice. Let's go through and just kind of look at the ones I asked you to work on last night. Okay, so we did 1 through 3 as a class, talking about shifts. So 4, 5, and 6 were the ones that we needed to work on. So I'm going to put up the answers here for those, just so you can see them. We'll talk about the shifts real quick on them. Number 4 hopefully was a lot easier after we did. I mean, it seems like it's a lot easier than some of the other ones we did. Okay, so if we're taking a look at this, in pencil here you'd have our graph of f. And then from that, you're just shifting everything down 4/3 or 1 1/3 units. So that point drops down, that point drops down, and that point drops down. Okay, asymptotes don't change. Okay, translation 4/3 unit down. Any questions there? Hopefully that one was a lot easier than like number 3 that we did. Okay, number 5 is a little tougher. Okay, multiple things happening. So first we have our graph of f in pencil there, and then it's a reflection over the y-axis. That's our negative, and then a horizontal shrink of 1/3. Okay. Nice. You guys are in the dark back there, man. The light went out. That's okay. We'll be okay. All right. So from that, please note that when you're doing a horizontal shrink, you're actually you're pulling in towards the y-axis. So things are moving towards the y. That's why this graph right here looks like it's thinner, like if you just look at the distance from y here and the distance from y here. It should be a distance, like this distance should be 1/3 of that distance. Well, actually, this distance here would be like 1/3 of 4 units up from there on this graph. Okay, so it's been moved 4. All right. Okay, so probably a better place to look if you want to see that is take a look at this length from here to here. And this length to here. Okay, they should be 1/3 of each other. Now, we didn't actually, most of us didn't calculate those values, but if we were to calculate those values, this would be 1/3 of that. Or excuse me, this would be 1/3 of that. Okay? All right. And the last one, number 6, we got a reflection over the x-axis. So we have our graph of f, we reflect it, then we stretch it by a factor of 3 and translate it 2 to the left. Okay? Now you can see the translation real easy with the x-intercept because the x-intercept doesn't get any closer to x because it's already there. But when we're stretching it by a factor of 3, you're stretching it away from the x-axis. That's why this distance, say right here, that distance would be 3 times this distance right here. That's 2 units away. And so if we were to actually calculate like this length and this length would be 3 times that. Or you would move up 1/3 of it here. Think of that one. Okay? Any questions on those? Yeah, Derek. Yeah, it would be. Like if you wanted to actually see if you did this right, I mean you could always do a table of values and you could just plug in values, but I mean, you could say, all right, when x is 1, 2, 3, 4, 5, and you plug it in, and then when x is 7, and you plug it into this one, so you got to plug it into the correct equation or functions, but you plug in 5 here, it should be the same as when you plug in 7 here, at least in terms of distance, like those points should be. So you'd have to take into account this and this, right? But if you're just looking at distance away, you're saying, okay, this is, for ease here, if this is 1, this would be 3. Okay? If that's the case, then yeah, it's one way to check it. Okay? Obviously not 1 and 3 on those. Good. All right. That was our puzzle time. Why don't you tell your neighbor what you got? Funny stuff, man. Lunch.